This is IMO 1967, question number 6. The question says, within a sports contest, there were M medals awarded on N successive days. On the first day, 1 plus 1/7 of the remaining M-1 medals were awarded. On the second day, 2 plus 1/7 of the remaining medals were awarded, and so on. And then on the last day, which is the nth day, all remaining N medals were awarded. We need to find out how many days were there on the contest, and how many medals were there altogether. So, let's list out the number of days, 1 up to N. The number of medals left just before the first day, we call it A1. That equals to M. Let A2 be the medals left before the second day. So before the last day, we had AN equal to N medals left. Let's say on the cave day, just before the day, there were 8 cave medals. And write down AK plus 1 as well. Now, according to what we are given, medals given out on the day. On the first day, there were 1 plus 1/7 of A1 minus 1. On the second day, it was 2 plus 1/7 of A2 minus 2. On the cave day, it was K plus 1/7 of AK minus K. So we get AK plus 1 equals to AK minus open bracket K plus 1/7 of AK minus K close bracket. This could be simplified as 1/7 of 6 times open bracket AK minus K close bracket. So this is what we got. A1 equals to M, AN equals to N, and AK plus 1 equal to 6/7 times open bracket AK minus K close bracket. From this we got K equals to AK minus 7/6 times AK plus 1. So let's list out some of the K's. K equal to 1, 2, 3, and so on, up to N minus 1. Now, we observe that there is a factor, 7/6, appears in all these terms. So, let's multiply this factor, 7/6, to all these terms apart from the first term. What we found is that if we sum up all these terms, some of the terms could be cancelled out. With the first and the last term remained. So, we got this equation. We call this result equation number 1. From here, we can move the term 7/6 to the power n minus 1 times n from the right hand side to the left hand side of the equality side. And then we multiply this all together by a factor, 7/6, to obtain another equation. Now, we observe that some of the terms could be cancelled out if We subtract the second equation from the first one. 7 over 6, 7 over 6 squared, 7 over 6 to the power 3, and so on. So this is what is left. By means of a well-known identity, we can further simplify and obtain an equation in terms of n for m. So m equals to 36 plus open bracket n minus 6 close bracket times 7 to the power n over 6 to the power n minus 1. Now note that 7 to the power n is not divisible by 6 to the power n minus 1 for any integer n. So n minus 6 over 6 to the power n minus 1 should be an integer. But this is not an integer, and for any integer larger than 1, unless n equals to 6. So n equals to 6 is the only answer, with m equals to 36. So this is what we got.